we're going to look at is 8a part IV. So when we look at this expression, there are an a squared, a b squared, a c squared, and a minus 2ab. So you may have noticed from the previous part of the question in part 3 that what you had was a quadratic trinomial with 3 of these terms in it. So what I'm going to do is going to rewrite this as a quadratic trinomial, and there's a term left over at the end. So we're going to put a squared minus 2ab and that's it, fully finished. So the trick of this question is being able to spot what terms make up the quadratic trinomial, and then seeing here that these two terms form the differences of two squareds. Okay, let's move on to 8b part 3. So we have to show that x cubed minus x squared is a factor of this expression. So I'm going to do this in both ways, both the area model and the traditional method. So first of all, I'm going to do the traditional method. So having a look at this expression here, we need to rewrite that including the missing terms. So what we have is 4x to the power of 5 plus 0x to the power of 4 minus 7x cubed plus 3x squared. Now we don't need to write any more because there's no terms left over at the end. There's no constant, so it's not missing an x term or anything like that. Okay, so we're going to divide that by x cubed minus x squared. So 4x to the power of 5 divided by x cubed is going to give you 4x squared. So we multiply our binomial by 4x squared. We get 4x to the power of 5 minus 4x to the power of 4. Don't forget to change the signs. So that becomes a minus, this becomes a plus. Okay, so we have one term, we have a remainder here, 4x to the power of 4. So we need to bring down the next term. Repeat the process. 4x to the power of 4 divided by x cubed is plus 4x. Multiply 4x by our binomial. So 4x times minus x is minus 4x cubed. Change the signs again. These cancel. 7x cubed plus 4x cubed is minus 3x cubed. We bring down our last term and repeat the process. X cubed dividing into minus 3x cubed is minus 3. So we multiply minus 3 by our binomial. And minus 3 times minus x squared is plus 3x squared. Change the signs. And you can see that our remainder is 0. So we need to state now, because the remainder is 0, therefore x cubed minus x squared is a factor. Now, it said find the other factors. So we have one factor here, and the remaining factors should be left over in this part. So can we refactorize our answer? Let's have a look. So we have (4x squared) plus 4x minus 3. Our guide number is minus 12x squared. Multiply the first term by the last term. We're going to fill up our area model box. First term and last term in here. So factors of minus 12x squared that will add together to give you 4x. So it has to be 2x and 6x, and because this is a plus 4x, the 6x needs to be a plus and the 2x needs to be a minus. So we fill them in here, it doesn't matter where they go. So let's identify any of the common factors that exist here. So on the top line, 4x squared plus 6x, well, the highest common factor there is 2x. Okay, so we divide 2x into 4x squared and we get 2x, and we divide 2x into plus 6x and we get plus 3. To get the last remaining factor, 2x dividing into minus 2x is minus 1. So our full factors, our final answer is x cubed minus x squared. So that was our original factor, and now we have our two factors left over at the end. So 2x minus 1 times 2x plus 3. Okay, I'm going to show you how to do this question using the area model. So we'll fly through quickly. Okay, so again, this is an x to the power of 5, so we would set this up using 5 columns. Okay, so we have 4x to the power 5, we're going to put that in here. What we really should do is again rewrite it. 4x to the power 5 plus 0x to the power 4 minus 7x to the power 3 plus 3x squared plus 0x plus 0. So we can put our 0 at the end, and we're dividing this by x cubed minus x squared. So it follows the same pattern. 4x to the power 5 divided by x cubed is 4x squared. So we're going to multiply our terms now to get this box. So 4x squared times minus x squared is minus 4x to the power 4. Now, having a look at this diagonal needs to add up to 0x to the power 4. So what needs to be in this box? Okay, so minus 4x to the power 4 needs to become 0x to the power 4, so this has to be plus 4x to the power 4. Okay, so we repeat the process. 4x to the power 4 divided by x cubed is plus 4x. Repeat the process. 4x times minus x squared is minus 4x cubed. Okay, having a look at the next diagonal now. So this diagonal is the x cubed diagonal, so we need to get minus 7x cubed out of this. So what do we have to add to minus 4x cubed to give you minus 7x cubed? That's another minus 3x cubed. Let's repeat the process. Minus 3x cubed divided by x cubed is minus 3. And minus 3 by minus x squared is plus 3x squared. Okay, we're almost finished. This is the x squared diagonal. Now just bear in mind that x squared was the last term in the expression, so we already have 3x squared, so what needs to be added to 3x squared to give you 3x squared? And the answer is 0. Okay, so 0 divided by x cubed is 0, so there is no further terms in this expansion. So what we have is x cubed minus x squared times our answer up here. 4x squared plus 4x minus 3. So it asks to find the other factor, so as we said previously that this can be refactorized, and it can be refactorized using the area model here, or you can split it up if you're able to do this in your head. 2x times 2x minus 1 is plus 3. Check your inner terms. Minus 1 times 2x is minus 2x. 2 times 3 is 6x. 6x minus 2x is 4x. So this is correct. Okay. We're going to move on to C part 1. So in C part 1 we had to factorize x cubed plus y cubed. So most of you will recognize that this is the sum of two cubes. So it's x to be cubed plus y to be cubed. So it's on page 9 of your books. A equals x and b equals y. Okay, so you might remember that the sum of two cubes is a plus b times a squared minus ab plus b squared. So we're going to fill up this. This becomes x plus y times x squared minus xy plus y squared. Okay. Next part of our question. Hence. So hence means we must write our answer from, use our answer from the previous questions. So we have x cubed plus y cubed plus 3xy times x plus y. Now, what part of this question was dealt with in the previous question? So what we should have recognized here is that x cubed plus y cubed, well, we've already factorized that from here. So what we're going to do is we're going to replace this, because we've already factorized, we're going to replace it with our answer from the previous question. So what we have is x plus y times x squared minus xy plus y squared. Now don't forget we have plus 3xy times x plus y left over at the end. Okay, we need to write this as a perfect cube, so that means that it's something in a bracket, x plus y in a bracket, probably to be cubed. So we need to find a way of expressing that. So we have two terms in this expression. We have this one and we have this one, and they're connected by the operation plus. So what common factor do each of these terms have? So having a look at this here, I can see that x plus y is a factor of this, and x plus y is a factor of the second term. So I'm going to chance factorizing it out. So we're going to divide by x plus y. So we divide by x plus y divided by x plus y is 1, and that leaves x squared minus xy plus y squared in the first bracket. Okay, in the second term, if we divide by x plus y, what we're left over is 3xy times 1. Right. At this stage, what we need to do is try and tidy up the expression a bit. So we have x plus y. Inside the second bracket we have x squared minus xy. We have plus 3xy left at there, and we have plus y squared at the end. Again, we can put these terms together, tidy them up, minus xy plus 3xy. So we have x squared plus 2xy plus y squared. So we're almost there now. If we have a look at this, this looks like a quadratic trinomial, so I can factorize it on the side using your area model. If so, you may spot it in your head, though you may be able to do it without working it out. So the guide number, so we put in our x squared, our y squared. Our guide number is x squared times y squared, so that's x squared y squared, and we're looking for an xy term in the middle, so it has to be xy times xy. Okay, and these are both pluses, so we put plus xy here, plus xy here, and we identify the common factors. So the common factor here is x, so x divides into x once, and x divides into xy y times. X divides into this plus y. So here we are. Here are the final factors at the end. So we've x plus y times x plus y times x plus y. And this is x plus y to be cubed. So that's our final answer. So that was relatively tricky, but again, spotting your quadratic trinomials in here is crucial to this question. Okay, part 3. Hence factorize x cubed plus y cubed plus z cubed plus 3xy plus times x plus y. So hence, again, using your answer from the previous question. So what we found from the previous question is that this term plus this term plus this term